Okay, right, so what we have here is a little bit of an experiment, well, a bit more than an experiment. There's about 10 years worth of different bits of work has gone on here. So a number of things going on here. Over here we have an Arduino Nano, which has been put into a breadboard, and it's connected to a set of variable resistors, which are acting as dummy voltage inputs. And then over here I've got pulse generator, square wave frequency generator, and just a little cheap thing that I got on eBay, which has been really useful, very accurate. You can set the frequency and you can set the duty cycle. So PWM output, pulse wave modulation. So what I'm going to do here is I'm going to load up Gambas3, the software development environment. Gambas is sort of the Linux version of Visual Basic, for want of a better word. And we've got, it's called Serial Port. I need to change the name of that, but this is the sort of prototype vehicle diagnostics, 1980s vehicle diagnostics system. Click on this. So there's the code, and there's the form. So let's see what happens when we run this. So it should run full screen. So we have full screen, and this could be set up to run automatically as soon as this tablet boots up. And by the way, just when I'm talking about that, you'll notice there's a little Windows symbol here. This is my son's old tablet. It was Windows 10. Wasn't terribly successful as a Windows tablet. Much more use as a Linux Ubuntu tablet. There was a wee bit of messing around to get Linux onto it. There's a couple of things don't work. The screen rotation, haven't been able to figure that out, so it's locked in landscape mode, and the cameras don't work. Apart from that, everything else is fine. So if I click open port, the Arduino is connected to the tablet by USB cable, just serial over USB. And oh, I hit close. There, that's it now. So there we go, and the data is now coming in from the Arduino. So there's just a few bits and pieces here. There's a status box here just showing that the the port is open, the settings, and then we've got here, this is the data stream. I call it a data frame. It consists of 18 characters. There's a less than sign at the beginning, and then there's 16 characters. This is just to make it that the data can be read on any kind of serial terminal for testing. But basically each pair of letters or symbols is 5 bits of a 10-bit analog to digital reading. It's just set up in such a way to say that they're all human readable characters. And then this is them interpreted over here. This is what they're decode at in decimal, and then this is them displayed on here. So let's see what happens. We'll go to one of the, put a screwdriver into one of the little potentiometers, and if I turn that, you can see the top one is moving up and down. So you can also see that the frame here, the data frame changes. Oh, okay, let's pick another one, just show I'm not cheating. Let's try this one here. They're not in any particular order, so that is number 3. So there's channel 3. Okay, and then the really whizzy one is over here. You'll probably not be able to see this. Oh, you can. You just about see it. It's at the minute it's outputting 100 hertz. Now 100 hertz actually translates on a 4-cylinder engine to 3000 RPM, but the 10-bit output only, it goes between 0 and just over 1000, so it's divided by 10. So up here you'll see 299. So there's a wee bit of inaccuracy in this because of the way it's very slight inaccuracy because of the way the pulses are counted by the Arduino. There's no it's all digital. So 299. So if I drop this down to 50 hertz, you'll see that one drop. Now I went a bit too far, 38. So at 50 hertz we should be getting an RPM of 150 or 1500 RPM. So there you are, 149. So it's within It's within less than 1% error, which is about right. There probably are ways to tidy this up and get less error, but no, it's not too bad. So I'm going to upload this, and yeah. So the idea is that eventually, if I can ever get my old bashed up sports car, 80s sports car going again, connect this up to the outputs of the engine control unit, tap into them via some high impedance amplifier, operational amplifiers, and then just as buffers, and then have this gizmo here up on the dashboard in a mounting. So when it's booted up, it would just come up like this. Would obviously tidy up the interface a bit. This is all written in Gambas, so it's easy enough to fiddle about with. Maybe have some dials and things, and good to go. Good to go. Okay, thanks for watching.